Hey mathematicians, Caitlin Henderson here with the first official lessons vocabulary. We are in Unit 8, Lesson 2. We're talking about dilation of segments, and we're going to go over some vocabulary words that I want to make sure you understand before moving on to the lesson. So first up, we've got quite a few vocabulary words here, and we are talking about what are dilations. So a dilation is a type of transformation, and it makes a figure bigger or smaller. So here in my picture, I actually have the original triangle here. And actually, let's make this triangle or this color orange, kind of like what's already there. So we have our original triangle right here. Okay, this is our original triangle. And if we were to dilate the original triangle, we could make it bigger. And making it bigger would create this green triangle right here. So this green triangle would be a bigger version of the orange triangle, or we could dilate it to make it smaller, and that would make this little blue triangle right here. Okay, so dilation, making a figure bigger or smaller. What you'll hear the text use is enlargement or reduction. So the green triangle is an enlargement of the original triangle, and the blue triangle is a reduction of the orange triangle. There's something that's super important to understand, and that is when we're doing dilations, we need to have a center of dilation, the point at which we are using to make the figure bigger or smaller. Now here in my example, I am using, and let's move me over here so that I can get a nice dark color. Okay, so over here, I am using a center point of dilation at the origin, 0, 0. Okay, this is a really beginner-friendly place to do dilations. And that basically just means that we are going to use this point and we are going to kind of create a series of rays here that allow us to identify what our ratio is, create a ratio, create our line segments. But ultimately, that center point of dilation is that fixed point that we use to make the shapes bigger or smaller. And if you can see here, we've got this, right? We've got these triangles that are coming off of this center of dilation at 0, 0 here. And it's getting bigger and bigger and bigger, right? And they're all, everything is getting bigger and bigger off of that center point, that center of dilation. Now, how it's getting bigger or smaller, right, depends on if we have what our original figure is if it's getting bigger or smaller. The scale factor is the ratio that is used to create our new figure. So here in this case, remember we start with this orange figure that I'm outlining in black. If we wanted to scale the figure up, our ratio is going to be bigger than 1, and that would create this green triangle here. If we had a scale factor that was smaller than 1, we'd multiply our orange triangle by a number that is smaller than 1. It would make this smaller one here. We're going to go more into this, but just know that the center of dilation is the point that we use to draw our figures. The scale factor is what we're multiplying the line segments or figures by to create our new figures, okay? It's a multiplier ultimately. Now, we're going to be talking about line segments mostly in this lesson, or in this unit, we're going to be talking a lot about line segments. Now, the thing that's important to note is what parallel lines are. We've talked about them before, but just know that the lines that go on and on and on and on forever and never touch. Line segments that we're going to be working with, they are a fixed distance. They're basically a line with a fixed distance, 2 endpoints that tell you where it starts and where it ends, right? Endpoints that tell us where it starts and where it ends. And when we're working here with our dilations, we are going to use slope as a way to determine if a figure is in fact a dilation. And just remember, slope is the steepness. We calculate slope by doing rise over run. Okay, rise over run. And that means that we take the change in our y values and we subtract it from, and we put it in a fraction over the change in our x values, okay? All of these are going to be needed when we go through the lesson here shortly, where we identify if two line segments are in fact dilations of each other, okay? All right. That is it. I will not dive deeper into the vocabulary. We will talk about it here in the next video. If you have any questions, reach out. And until next time, guys, bye.